Hello everyone. Section 3.3, Statistics. We're rolling in Chapter 3. We're coming to a close here. So we're talking about measures of relative position, obviously. And one of those measures, let me check here. I'm going to get a pen rolling so I can make marks if I like. One of those items we're going to talk about are percentiles. So percentiles. First formula you might want to put down on your formula list. L equals N times P over 100. So what does L represent? L is where that item is in the ordered array. Remember, it has to be in order, lowest to highest. Where is it? First, second, third, fourth, 19th, that's what L represents as a number. N represents how many data items you've actually got in the whole list. P is the percentile you're interested in. And using this formula, you can find where you can find this percentile. So when you get this, remember, bump it up to the next larger total number. If it happens to come out to a whole number to begin with, still bump it up. And that's where your whatever percentile is. So if you're looking for the 28th percentile, we've got 28th percentile. Put that 28 in where the P is. 100 is 100, and depends on how many data items you actually have. Remember, they're ordered from smallest to largest, and using these two items here, bump it up, or if it comes out even, still bump it up one more, and that'll tell you where to find it. So here's your list of numbers, let's say. First one is over here, the last one is over here. You just count up here until you get to, for example, maybe it's the 17th one that comes up with this L. Here's an example we can use. It's a rather large one. What you might want to do is go check out the PowerPoint for this one and print out these next 3 pages. What you've actually got is a stem and leaf plot, which means you've actually got all the data values and they're in order. It's an ordered stem and leaf plot. 135 different vehicles. And there's the first page. Just a little bit reminder about a stem and leaf plot. This is the stem. That means this is the beginning for each of these data items. So this one represents 1, 2, 1, 121. This one represents 1, 5, 6. Throw in another one here. This one represents 1, 9, and 3 for the leaf. That's how they go. So all the data are there, and the nice thing is they're in order too. Here's the second page, and there's the last page. So you might want to print those out. Now, if you don't have the PowerPoint in front of you, what you could do is you could do a print screen for those 3 slides from this video. Print those out and have them by your side as you're going through some of these questions. So first of all, find the value of the 10th percentile. So you're going to look for where you can find this. Where means L. And you're going to take the 10. See back here? Oops. There. 10 on the top, the 100 on the bottom, and the number of items. Now we've got 135 items, so we'll multiply those, and we get a 13.5. This is really 1/10. 1/10 of 135 is 13.5. Remember, if it doesn't come out even, bump it up. For what we need, we're going to look for the 14th item in this list. Let's check out the second one while we're at it to see where we would find this one. L equals P, the percentile, over 100, always 100, and we've got 135 for this one. We want the 20th percentile, so the one we're looking for is 20 over 100 times 135. That's 0.5, oops, sorry, 0.2 times 135. That gives you 27. Notice that comes out even. But the second rule says if it comes out even, bump it up one. So we want the 28th item in the list. All right, so we need the 14th for part A, and we need the 28th for part B. How do you find those? Okay, let's sneak back here a moment. We'll use this first list. I guess that's a little bit too far. Oops, I went the wrong direction. Excuse me. My apologies. Okay, there's our list. Now, first of all, we went to 14th. And these are all in order. So, let me change the pen color here for a second. We'll go with black, maybe. Okay, so this is the first date item right here, this 121. So this is the first one, second, third, fourth, fifth, sixth, seventh, 8, 9, 10, 11, 12, 13, 14. There's our first one. So this is the 10th percentile. The 10th percentile is 173. How about the 20th percentile? Well, we're up to 14. We need to go up to 28, so we need 14 more. So there's 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 28. There's our number. So for the 20th percentile, I'm just shortening that. We've got 193 is the 20th percentile. And 173 is the 10th percentile. That's how you work it. So let's get caught up here. We went through that. Remember, they have to be in order. There was a 27 we bumped up. 28. Now if you want to go the other direction, you might want to write down both those formulas, or you might just want to write down one. They're basically the same thing algebraically. Because remember, the other one was L equals P over 100 times N. That's the same thing as this. Solve for L, multiply by N, there's your N, divide by 100, divide by 100, and you've got it solved for L. So these are really the same thing. But for convenience, you might want to have both on hand. Now, remember, L is how many values are less than or equal to the given value. So you're going to look for your value and get the number less than or equal to this data item. And when you get the percentile, round it up to the nearest whole number, excuse me. Whether it's up or down, it doesn't make any difference. It's always represented by a whole percentile, no tenths or hundredths of a percentile. So that makes it pretty easy. So in the previous example, the Nissan Xterra averaged 21.1 miles per gallon. What percentile is that? So sneak back here. What's your formula? P equals L over N times 100. P equals L over N times 100. 100 is to make it a percentile. We're going to have to first find out where it is. So if you look at that, it says 21.1 is repeated in the data set in the 48th and 49th positions. So we're going to pick the largest one, 49. And since we've got 135 data items, and we're using a location of 49, put 49 in here, 135 is the total, always by 100 because it's a percentile, and you get 36.3. And what did it say? Round it. This rounds down. You don't need to be rounding up. Just round it to the nearest whole number. And you got your answer. You need the 36th percentile for that Nissan Xterra. That means that 36% of those cars have an MPG rating lower than the Xterra. It was Nissan, whatever. I'm sure you know. Next, quartile. Some of you have already seen this. To talk about quartiles, remember that means a quart is 1/4 of a gallon, and this represents taking all the data items, chopping it in half, and chopping those halves into half, which gives you 1/4 here, 1/4 here, 1/4 here, and 1/4 here. So these quartiles split the data into 4 pieces. Now we don't have anything up here. This is the first division line. This is called Q1 or quartile 1. The one at the top here is Q3, and by default this would be Q2, but we usually refer to this as the median. Let me write that again. Median and Q2 are the same thing. So note the first quartile, that's up here. 25% of the data, 1/4 of the data are less than or equal to that. Second quartile, also known as the median, 50% of the data are less than or equal to that because it's right in the middle. And the third quartile represents the point where 75% of the data are less than or equal to that value. Here's Q3, and you've got 3/4 of the data where 75% of the data is less than that. So those are quartiles. we're going to ignore the hinges. That seems to be an issue, and we're going to ignore that totally. As long as you represent, or as long as you understand what quartiles are, we're in good shape. We're not going to get into political matters about hinges versus quartiles. So it says, find the quartiles for the MPG data used in the previous examples. Okay, there's 135 numbers. It's going to take you a little while to put those in your calculator or your spreadsheet, whichever way you care to do this. However, once you do, this whole thing can be pretty easy. So first of all, put those numbers back in. Here's a list again, in case you want to do that. One probably will be good enough for you. Most data sets that you're going to be working with won't be anywhere near this big, so don't be too concerned. Do it once and that'll be fine. So you'll need to put in 121, 133, 141, 155, 156, 161, 161 again, 167, 168, and so on. Here's your second page of data and your third page of data. Now, we're not going to do that. Use TI, whichever you're using. The 84 or the Inspire. I forgot. Some of you have 83s too. Whichever one you're using, use that instead. Put the numbers in, be very careful. Take it slowly because you don't want to go back through that 2 and 3 times to double check. Take it slowly, check it as you go. Notice they're in order anyway, so that should help you a little bit. Put those in, go to Stat, Calculate, one variable stats, oops. And all you need to do is cursor down. I think you can cursor the whole way down to the bottom. You can get Q1, median, which is another way of saying Q2, and Q3. While you're at it, you might as well take a note of two other things that are right next to it. Min-X is right before Q1. Right after Q3 is Max-X. And spoiler alert, this is the 5-number summary of your data values, of your data set. This gives you an idea of what the data looks like, what's the biggest, what's the smallest, what's right in the middle, and so on. Those 5 numbers are really handy to get a quick picture of what your data set looks like. So moving along, we're not going to do that. We're not going to do that. I told you how to go there. Forget the approximation method. Instead, this is what you should get when you get to the end of your long venture of putting all those 135 numbers in. Okay, here are some ones that are not going to be nearly as painful. If, for some reason, you did not go through that operation, do both of these. Find the quartiles for each of those, and you know we're going to use TI, and I don't know that any of you are using Excel, but that's an option too. Find the quartiles for both of those sets. Pause your video right here. I'll be here when you're ready to go. And Pause. All right, assuming you're back, by hand, you can get this. It's not too bad. I still would use the calculator. Do you trust yourself more than the calculator? It's up to you. Using the TI-83, 84, this is how you do it. If you're using the TI Inspire, you can still, if you've gotten to this point, you probably know how to get to one variable stats. Start with the menu, the statistics, and so on. So this is what you would see on a TI-83 or an 84, for example. Notice you've got 5-number summary at the bottom of your list. Up above here are more items that you saw to begin with. This is the bottom of your list of data items from one variable stats. This right here is your 5-number summary. You can actually use that 5-number summary, as we'll see in a few minutes, to actually create a small graph, and you can even use your calculator to create this small graph using those 5 numbers. Actually, the calculator will almost do it for you. Look on your keypad right now, just for the fun of it. See if you can find something called stat plot. It's the second function above y equals, if I'm not mistaken. We'll get back to that though. There's the second group. Hope you got those. There's your 5-number summary. The minimum, and if we are going to talk about the TI-84, for example, there'll be your min-x, Q1, Q2, also known as a median in there, Q3, and max, x. 5-number summary gives you an idea of what's going on with your data set. The biggest, smallest, that tells you something, the median tells you something, and the Q1 and Q3 can be handy as well. It tells you where they start and where they stop. That can be handy. So what's the 5-number summary for the data in example 3.3.3? I don't remember what 3.3.3 is. Do you? You can go back and check. There are your numbers. And the 5-number summary is right at the end of the last sentence. You can read that for yourself. Next. Okay. Here's one thing we can use the quartiles for. The interquartile range, short SIQR, you can calculate by just subtracting the 2 quartiles, the 3rd quartile minus the 1st quartile. Notice that gives you how widespread the middle 50% of the data are. Q3, 3rd quartile, Q1, 1st quartile. It's an important one because it's going to help you find some interesting things about your data set. So, we can use that to create a box plot. You start with a horizontal line, a number line in other words. Make sure all the numbers in your data set will fit on that number line that you're drawing. So first of all, start with that number line. I'm going to go back to red. If you don't mind. Hope you don't. Anyway. There we go. Okay. Now, draw a small line segment above or next to the number line to represent each of the numbers. In other words, here's our number line, and what we're going to do is we're going to put marks like this for the 5-number summary locations. Now you're going to take the first quartile and the third quartile, and you're going to create a box. So this is the first quartile, this is the third quartile. So you'll create a box like this. The median's going to be in the middle. Then you'll connect the box to the last numbers in your summary, like this. This is called a box and whisker plot. This is the box in the middle. That represents how big or how widespread the middle 50% of your data is. These on the left and right show you how widespread minimum and maximum spread the data. These parts at the end are also called whiskers. That's why it's often referred to as a box and whisker plot. So here's our 5-number summary. There's our horizontal axis, which covers all those data items. There's our data. And we can put all our data there. Notice that we started 0, went up to 60. If you look back here, that covers all of these numbers. All of those can be graphed there. Label the axis of even intervals. Don't jump by 10s and then by 20s and then by 30s and by 5s and so on. Make sure that it's evenly distributed when you make these marks. You can do it easily in Excel. Second, place a small line segment above each of those numbers in the 5-number summary. So there's where the minimum is. You put it above the axis, but there's about where our first number is down here. Q1 is about here, and so on. And there's the maximum. It's up here. Keep it above it so you don't get mixed up between the box and whisker plot and the actual real number line. That's sort of what it should look like. This gives you an idea of how widespread the mid 50% is. Notice the middle 50% is pretty compact. Whereas, look over here, this one's at quite a distance away from the box. This one is sort of in between. It's not too close, it's not too far away. Moving along, there's our box and whisker plot. You could fill in the box if you want to be artistic. Actually, Excel might do that for you because Excel is pretty handy about putting colors and different shapes in there for you. That's what the box and whisker plot looks like. It gives you an idea of something about what the data looks like. Notice in the middle 50%, the median, is Q2, is just a little bit to the left. Now, with the U.S. Geological Survey website, use these box plots to answer some questions. All right, here are box plots. First one, second box plot, third, and fourth for box plots. Notice that you got the 75th percentile, that's Q3, 25th percentile, well, or I label this Q1, Q3. Well, for some reason, I'm not sure why. I haven't been able to notice. If you find out, let me know. But this whisker ends at the 90th percentile instead of up at 99%. This one doesn't go down to 0 or 1%. Anyway, you can compare these data by just looking at the box and whisker plots that are graphed together. Some of these overlap, some of these don't. That can be important if you're comparing them. So what do the top and bottom bars represent? See if you can answer some of these questions. Hit pause, see if you can answer them. Go back if you need to take a look at that again. See if you can answer those 4 questions. We're getting close to the end, so relax a little bit and see what you can do. All right, let's move on then. In the top one, we had the 90th percentile of the average at the top, and the bottom bar, the 10th percentile. Don't ask me why, as I said, I don't know. The highest median average was Missouri, so you can just look at the different median averages and pick which one's the biggest. It depends on what your questions are and what your job is, really, or what your questions are. The one that had the largest interquartile range, D, take a look back here. See? This one. The biggest interquartile range right here. It's the middle 50%. Okay. Now, the idea of this one is you want to find out if there are any really unusual numbers in our data. Here's where the interquartile range becomes helpful. And be careful. First of all, you find the interquartile range. Subtract Q3 minus Q1, that's easy. Write these steps down. It might not be intuitive. So first, find the interquartile range, subtract Q2 upper and lower quartiles, multiply that interquartile range by 1.5. Next, remember the box and whisker plot we just talked about. What you're going to do is find this value right here. Let's call it D for the time being. 1.5 times the interquartile range. What you're going to do is go from Q3 and go a distance D. Where does that put you? Do you have any data that are further away than D is from Q3? And on the other side, you go to Q1. Go distance D in this direction. See if there's any data out here that are beyond that. If it's beyond on the left side or beyond on the right side, then you call it an outlier. One of the things you might be concerned about is there something wrong with that data? And that's a possibility. Another possibility is there's something here you need to investigate. That's why this is important. Using the interquartile range, multiply it by 1.5, go to the right from Q3, to the left from Q1, see if anything is beyond those limits. Those would be outliers if they exist at all in your data set. And you need to investigate to see why they're there, if possible. So here are some commuting distances for some summer interns. Find the interquartile range. Use the IQR to identify the outliers in the data set. So, the interquartile range, subtract the quartiles, we get 18.2. Do you remember what we do next? If you said multiply by 1.5, you're right. Multiply by 1.5. Subtract that from Q1. So we're talking about items on the left. Are they this far away or farther? And then take Q3 and add that value. See if you've got any data items that are beyond that. Now on the first one, this is a left-hand limit for outliers. Notice that for this particular kind of value, we're talking about something that can't have a negative value. So you would scratch that out and you have 0 there. You won't have any outliers in the negative range, period, for this one. On this one, you're going to look to see if any of your data are further out than 49.4. Well, actually, there is one, 49.6. Not by much, but it is over. So there you've got an outlier to the right. Last of all, we're talking about the standard score. And sometimes that's referred to as a z-score for perhaps obvious reasons. The way you calculate that is if you're talking about a population, then you take whatever data value you've got, subtract the mean, this is the mean for a population, divide by the standard deviation, that's the standard deviation for a population. That gives you a z-score. Z positive means above, the mean or above average. Z negative means whatever data you have is below the mean. And very simple for a sample, you're still taking the data item, subtracting the mean, dividing by the standard deviation, but this is the mean for a sample, it's called X bar, and this is the standard deviation for a sample. Same calculations. One thing that it enables you to do is to compare things that you shouldn't be able to compare otherwise. And it's simple. For a z-score, this is a good one to remember. Don't keep a ton of decimal places. 2 decimal places will be sufficient for z-scores. Here's how you work one of those. So if the mean score in the math is 500, that's the mean. That's been established over history. You've got a standard deviation there of 100 points, and that would be sigma, small sigma. What's the standard score or z-score for that student? So for the z-score, take that actual score, subtract the mean, which in this case is 500 for the math SAT, divide by the standard deviation, which is 100. So you have 130 over 100. So that person's z-score is 1.3. And that tells you a little bit. It tells you that, first of all, because this is positive, they're a bit above average for their math score in the SAT. If it had been negative, that would be meaning that they were a little bit lower than the mean score for people who took the SAT. There we go. A bit of a summary. Perhaps you like their writing better than mine. Now, here's one that talking about Jody, and she scored an 87 on her calculus test, and her friend Ashley scored an 82 on her calculus test, but they were in different sections. How do you actually compare them because they're in different sections? Well, you can compare them by using z-scores. So, for Jody, what's her z-score? Well, she scored an 87. On her test, the mean was 80, and the standard deviation was a 5. Let's figure out what her z-score was. 7 over 5 Jody's Z-score was a 1.4. Notice the positive, so she was a little bit above average in her class. Now, how about Ashley? Here's for Jody and the Z-score for Ashley. Her score was a 73. At first, that doesn't sound like she did anywhere near as well as Jody. But the mean on her test was this, she scored an 80. I'll just scratch that out. She scored 82, which wasn't as high as an 87. But the mean on hers was 73, and on hers the standard deviation was 6. So if we subtract those, 9 over 6, and Ashley's Z-score was actually 1.5. So she did better than the average student in her class. And not only that, but comparing the classes, Ashley actually had a little bit better result than Jody did. And that, folks, wraps it up for this section, 3.3. I hope you're doing well. If you have any questions, contact me and we'll make arrangements for getting together and getting you back on track. Until next time, keep smiling and bye-bye.